So hello guys, welcome back to my channel. So today I'm here with few quotes to just explain you all that how is it all working. So first of all, we have defined our structure for array, that is int a and then int size and then length. For displaying the array, we have written this function, that is int I, and for I equals to 0, I less than arr dot length I plus plus cout arr dot a of I. So for traversing or displaying an array, we have to use a for loop. Now for adding an element in an array, first of all we have to check whether the length is less than size or not. If the length is not less than size, then we can't add any element further. But here, if the length is less than size, then we can add length like a of length x. We have added here. After this, we are going to show insert function. So for inserting, we have defined here a structure, then int index where we want to index, where we want to insert, and the int x, that's what value we are going to insert. So int I, and first of all we have to check whether the index is greater than or equals to 0 or should be less than equals to length. So for traversing through an array, we have used here for loop for I equals to arr length and I should be greater than index I minus minus, because in this function we are traversing from backward side, so that's why. So now a of I, it should be a of I minus 1, and at a of index we should insert x and then increase the length. Okay. So now we have written a small swap function here. We all know that in temp and then temp equals to x, x is equals to y, and then y equals to x. It's a small swap function for reference only. Now for linear search, we have defined our structure array using a pointer. Then int key, the key is the value which we want to search in our array. Now int I, for traversing through an array, we have used for loop for I equals to 0, I less than length, and then I plus plus. If our key is equals to a of I, then swap a of I with a of 0. This method is called move to front method in linear search. If it's true, then we should return I, that is I is what? I is our index. And if it is not true, then we have to return -1, that key is not found here. Now for the binary search, we have again defined our structure array and then the key which we want to search. Now here we have defined low as 0, high as length -1, and mid. So our loop will continue as long as our low is less than or equals to high. So now here the mid is low plus high by 2. If key is equals to a of mid, then simply we will return our mid. But if key is less than a of mid, then high should be mid -1. And else, here else means if key is greater than a of mid, then low should be mid plus 1. And if the loop will continue, and if neither of the condition are going to be satisfying, then outside the while loop we are returning our -1, that is key is not found. Now for the recursive binary search, here we have introduced an array low, high, and key value. And now again int mid low plus high by 2, and while low is less than equals to high. If key is equals to a of mid, then simply return mid, and if key is less than a of mid, then here we are calling our function recursively, so that's why I have written here again like a mid. If key is less than mid, then improve the high with mid -1, and if key is greater than mid, then improve the low with mid plus 1, like that. Now for getting an index in an array, we have written this function like int get struct array AR or int index. If in now the condition for our index we have seen above, and if it is satisfying, then we should simply return a of index, that is the value at a of 0 index, like. Okay, now for setting a value at a particular index, we have defined our structure, then index, and then the value which we want to insert here, that is x. So now our index condition is written here. So if it is satisfying, then we should write a of index as x. Okay, now for finding the maximum in an array, we have int max struct array ARR. Now we have initialize our max as a of 0. So for traversing through an array, we have use here for loop. So if a of I is greater than max, then we have to initialize max as a of I, and this loop will continue as long as it is not get max, and after getting the max element of an array, it will simply return max. Now for main function, the logic will be same, just here we have using less than sign. Okay, so here no need to explain the main function, you all can understand by your own. Now for sum, we have defined our structure array ARR. Now we have used here a variable s, which is storing value 0, then int I. Now for traversing through an array, again we have used our for loop. Now the sum should be equals to sum plus a of I, and then simply return s. Now for getting a float, for getting an average, we have simply returned the float, because already we have written our sum function, so I'm not going to write it again. I'm directly taking it from my written function, that is the sum of array divided by length, and then it will simply return, but our average will be always in float, that's why I'm mentioning here float. So here I have written so many functions for your easy understanding, so you can get all it here. Now if you want me to run anything, like what you want me to run, so here I can display you the max function. So for max, it should return what? It should return 10. Okay, so here it is 10. It means my max function is correct, and similarly my every function is correct. Like if you want me to run my recursive function, so I can also run my recursive function. Here I'm going to run my recursive function. Recursive function ARR of if my low is 0, my high is length minus ARR of length, and then which key I want to search. I want to simply search 10. Let's see, is it giving me 4 or not? Yeah, so it is giving me 4. That's my answer is right. So in this way my every function written here is correct. You can check it on your own and can practice it from here. So I hope this video has helped you, and so thank you so much in this video. See you in the next video. Thank you so much.